Logarithms. The hardest part about logarithms is spelling it right. And that won't even be tested, so you'll be fine. Logarithms. We're going to start with something that really is going to seem almost trivial. You're like, why are we doing this? So go with me for a minute here. 5 plus 3 equals 8. You're like, yes, good. I can follow that. Do you know how to rewrite that as a subtraction problem? Like use the same type information, but rewrite it as a subtraction problem. So there's 2 ways to do it. Yeah, 8 minus 3 equals 5. Man, you guys are good. You paid attention in 3rd grade or 4th grade or 2nd grade maybe, I don't know. Let's step it up a notch here. 6 times 4 equals 24. That's a multiplication problem. Could you rewrite that as a division problem? You're like, yes, why are we asking? Why are we doing this? 24 divided by, I guess you could pick either one. 24 divided by 4 equals 6. And so you're still thinking, okay, what does that have to do with logs? Because logs and exponents are inverses. They undo each other. And so they have kind of a similar relationship as adding and subtracting. It's like they're sort of the same thing, but they're not the same thing because they're the opposite. Multiplying and dividing, kind of the same thing, but also kind of opposite. Logs and exponents, kind of the same thing, but also opposite. And so the first thing we'll look at is how to translate in between logs and exponents. How to take a log expression and rewrite it as an exponent expression. Or the other way around, how to take an exponent expression and write it as a log expression. Just like you did with adding and subtracting, multiplying and dividing. I guess we could have put 2 arrows on those. You know how to go back and forth between those. That's what we're going to do. So we're going to end up with kind of a column of log statements and a column of exponent statements. We'll start with one that's just super generic with just letters in it. Log base A of B equals C. I guess we should first talk about how to say that. Log base A of B equals C. So you've got to get those words in there. You don't just say log AB equals C. It's log base A of B equals C. And we want to translate that into an exponent statement. And my favorite way to do that is with a fishhook. Y'all heard of that before? Seen that before? No. Huh. Well, start at the base. Loop to the other side. Start at the base, loop to the other side. So the base is A. Then we're going to fishhook around, or some people call it the loop-de-loop method. But it kind of looks like a fishhook, so I like that, call it that. Start at the base, loop to the other side. And then you're going to write your exponent equation basically in the order that you see, in the order that you did your fishhook. So A to the C equals B. By the Fishhook method. Log base 4 of x equals y. Why don't you try that one? So apply that same fishhook thing. Start at the base, loop around to the other side, and then write the exponent in the order of the fishhook. Some people will physically draw the fishhook every time. Almost everybody at least, kind of traces it with their pencil so they can visually see what's going on. So 4 to the y equals x. This becomes the basis of almost what we're going to do the rest of the unit. So this is super important, really, because we don't really like using logs. So as often as we can, we say, you know what, I'm not super familiar with logs. Let's just rewrite it as an exponent. And that's a lot of times how we'll solve the problem is, forget this, I don't like that. Let's rewrite it as an exponent and figure it out. All right, log of x equals 3. So there's a missing base. Do you know what the missing base is? The invisible base there? It's 10. Right? And maybe that seems weird that it's not there, but there's a whole list of missing numbers that you're used to in math class. Right? If there's a missing coefficient, that means the coefficient's 1. If there's a missing exponent, well, it's 1. If there's a square root that's missing, or a root that's missing, kind of just gave away the answer there. It's really a square root. So there's lots of times where if it happens often enough, we just kind of agree that we're going to leave it off, and everyone knows that if it's not there, we're talking about base 10. So we can still rewrite this. We just have to be careful. The missing base is 10, so 10 cubed equals x. ln. If you've looked at your calculators, you've maybe noticed that there's a log button and an ln button. It's also a log, it just has a different base. It's a little bit more complicated one here. Natural log of 14 equals a plus 2. You know what missing base goes there for a natural log? Nope. It's e. Missing base is e for a natural log. And that's why on the calculator, the e and the natural log always go together. So you look at the calculator. In fact, some people use this to remind them of what's going on. Log and 10 to the x, those buttons are kind of the same. You just have to hit second to get the 10 to the x, because that's a log base 10 button. ln is log base e. So if you ever get confused, you can just say, hey, can I borrow a calculator? I don't even need to use it. I just need to look at it, because that will remind you that ln is base e, log is base 10. So when we do the loop-de-loop for this one, for the fish hook, we got to be careful on the other side, because it's e to everything that's over on the other side. So e to the a plus 2 equals 14. So start at the base, loop around to the other side. Start at the base, loop around to the other side. Now we're also going to go the other direction. We're going to start with things like b to the 5th equals 7 and go backwards. It's not backwards, it's just the other way. Like addition, subtraction, subtraction to addition. It's kind of forward, backwards, whichever way you want to start with. The good news is the fishhook method still works, and it still works in kind of the same way. You're going to start at the base, but the base is B, and loop to the other side. So again, you make a fishhook, and then you'll write the letters down in the order that you fishhooked them. So log base B of 7 equals 5. So the fishhook works the same way in either direction. That's kind of the nice thing about the fishhook. Start at the base, loop around to the other side. All right, you try that one. 10 to the x equals y. Start at the base, loop around to the other side. And lots of you draw in the fishhook, and that's completely okay. So log base 10, so the 10 is small, it's a subscript of y, so y is the same size and on the same line with log, equals x. That is a great question. Are we supposed to write the 10? If you write the 10, I'm going to take off a point because you don't need to write the 10. It's not really wrong, it's just preference. So we'd rather write it as just log of y equals x. So some of you did that, others of you were like, wait a minute, there's something with the 10 going on there. Let's do one more of these and then we'll move on. But this is super important for the whole unit. So we got to get this fishhook thing right in either direction. E to the 6 equals x plus 3. So fishhook that one, rewrite it as a log. Start at the base, fishhook around, log base E, whoops, that means something else, but I already wrote it, so I'll fix it later, of x plus 3 equals 6. But log base E, that's the same thing as natural log. So natural log of x plus 3 equals 6. Yes. Okay. Because log base E, this is sort of like an unreduced fraction. It's like, well, it's not really wrong, but it's not the best. So rewrite it as natural log. And you definitely need the parentheses, otherwise you're only taking the natural log of x and then adding 3. So be careful about parentheses, who you're taking the log of. Alright, you're going to see really quick how often we use the fishhook thing, because we're going to evaluate some logs. The good news, well, I guess it's good news and bad news. Bad news first, always, right, is that we're evaluating logs and we're not real familiar with logs. The good news is, you know what, now we know a way to change a log to an exponent, so, you know what, we're not really going to evaluate logs, we're going to evaluate exponents. Because everyone is far better at exponents, maybe not everybody, most people are far better at exponents than they are at logs. Show you what I mean. Log base 7 of 49. Probably your initial reaction is, logs, I'm not too familiar with logs. That's fine. I'm trying to figure out what log base 7 of 49 is. I don't like logs, really. I'd rather work with exponents. So rewrite the thing as an exponent. So this means 7 to something equals 49. Hopefully when you write it as an exponent, your brain immediately says, oh, well, that's an easy one. That means That means the answer is 2. Log base 7 of 49 is 2. Some of you will get to where, if you know exponents well enough, you don't write that step, but you're still doing that step in your head. That's the only way you answer this question. So even if you don't write 7 to something equals 49, in your head you're thinking, okay, this means 7 raised to something is 49. So even if you skip drawing the fish hook and writing the line, like your brain is still doing that. Log base 4 of 1/16. Well, that one's a little bit harder, so I would probably want to write that one out. So 4 to the something equals 1/16. 4 to the something is 1/16. Why is that thing a fraction? What type of exponent flips it over? It's got to be negative. So negative for sure to get the flip. And then how do I get from 4 to 16? Square it. So my answer is negative 2. 4 to the negative 2 is 1/16. So log base 4 of 1/16 is negative 2. So yes, we're doing log problems today, but if you know how to fish hook, we're not really doing log problems. We're going to change them into exponent problems, and then they're just a lot easier to handle. Natural log of e to the negative 3.6. This one is far easier than it looks. Natural log of e to the negative 3.6. What's the missing base down here? E. So some people will even write it in, like, because they want to do the fish hook, they don't want to mess anything up. It's like, well, I know there's an e there, so let's write it in and then do the fish hook thing. So this means e to, I put a box over there. Some people introduce a variable and make it an exponent, or make it an x or a y. You can do either one. I guess I could do it that way. I could put an x over there. So e to the x equals e to the negative 3.6. I don't know what e to the negative 3.6 is, but I think by looking at that problem, I think I know what x is. All right, if the e's match, then the x's or the exponents need to match. So x is negative 3.6. So it looked hard, but it's kind of a rigged problem to work out okay. Speaking of that, the log of 10 to the 4.8 pi. Well, that looks terrible, but do the fish hook and see what you get. Again, the missing base is what's important here. There's a 10 there. So 10 to the x equals 10 to the 4.8 pi. And then hopefully as soon as you write that, you're like, oh, well, that's a really easy one. I don't know what 4.8 times pi is, and I definitely don't know what 10 to the 4.8 times pi is, but I can match the pieces, and x has got to be 4.8 pi. So there's a few on the worksheet that are kind of sneaky like that. Sneaky easy, as long as you recognize what's going on. Roman numeral 3, and final. Solving log equations. Well, again, we don't really like logs. We know how to fish hook, so wrong. We're going to solve exponent equations. Well, I mean, they're going to be log equations, but we're going to change them into exponent equations. it's really the same thing we were just doing, except we've moved the x around. But it's still the fishhook. So do the fishhook, and then figure out what x is. So fishhook, 9 squared equals x. And most of them are really this easy. Like the test isn't the math of it. The test is, can you fishhook right? And if you can fishhook right, well, 9 squared is 81, so x is 81. Number 2, log base x of 64 equals 3. Well, again, initially you're like, I don't really get logs yet. I don't understand how they work. What's going on? No problem. Fishhook it, turn it into an exponent equation. X cubed equals 64. Still requires a little bit of thought. What times itself 3 times will get me to 64? You know, if we're giving you a problem, the answer is not going to be, 2.7843. It's going to be something normal. And it turns out to be x equals 4. Again, logs seem scary, but once you learn how to fishhook, you're not really dealing with logs anymore. You're dealing with exponents. Now, if exponents are scary, well then we've got some work to do. But we're hoping that exponents are at least somewhat comfortable for you. Why don't you try that one? Log base 5 of 1/25 equals y. Again, fishhook, fishhook, fishhook. 5 to the y equals 1 over 125. So we still need to know about exponent rules and how exponents work, but we've at least removed the log from this equation. So let's see, it's flipped. So that means y has to be negative something. That would do the flipping. And then how do I get from 5 to 125? You would cube it. So y equals negative 3. Last one. Log base a of the 4th root of a equals z. Initially, maybe that one looks weird because there's 2 variables in there, so what's going to happen? Rewrite it with the fishhook and see if you can figure out what's going on. So a to the z equals the 4th root of a. Saw that on almost everybody's paper walking around. Then it's like, okay, well this doesn't really match up exactly, except that the 4th root of a, I could rewrite that as a to some power. If the power's on top and the root's in the bottom, then this is a to what power? 1/4. So it's a to the 1st, but the 4th root of it. And so you got a to the z equals a to the 1/4. Oh, well, even if I don't know what a or z, well, I do know what z is, regardless of what a is. Z's got to be 1/4. So people get worried about logs. They don't like logs. They don't understand logs. Fishhook it, and then you're not dealing with a log anymore. And so that's almost completely what, not almost, that is completely what today's worksheet is. So again, you've got the worksheet. It's worksheet 3. The graphs we'll say for, well, not tomorrow, but Wednesday. So just the front side of that worksheet, worksheet 3, sorry. Unit 5, worksheet 3, 1 through 18. So it's 18 problems, but it's every single one of them is a fishhook problem. And so with 15 minutes left, you can probably finish that. Actually, let's do the first one together to make sure you understand what I'm asking for. So get your worksheet packet out, and we'll do 1 and 4 together. Oh, what the heck? Let's do 1, 4, and 7 together while we're on a roll here. So number 1 says rewrite the expression in exponent form. So that's all I'm asking you to do is fishhook the thing. Like, the fishhook part is so important that the first 6 questions, all we want you to do is fishhook. There's no solving. They're not, just fishhook the thing. 10 to the 2.8751 equals 750. And that's the end of that problem. I don't know if that's right or wrong. I don't understand what's going on. All I want you to do is fishhook. Number 4 through 6, same thing. Rewrite the expression in log form. So you don't have to solve anything. You just got to fishhook. So log base, and then again write the numbers or the variables in the order that you fishhooked them. So log base x of 2025 equals 5. And by the way, if you're ever not sure if you fishhooked correctly, you can fishhook again and get back to where you started. Like this is the answer, but if you fishhook the answer, x to the 5th equals 2025, that's where we started. So it's a real easy check on your answer to just fishhook what you wrote down and see if that was the original problem. So this would be log base 10 of 750 equals 2.8. Yep. Fishhook, fishhook, fishhook. Number 7, evaluate. Well, again, I'm not going to evaluate logs. I don't like logs. I'm going to evaluate an exponent. So 10 to something equals 10,000. Well, I guess that requires a little bit of thought, but 10 times 10 would be 100. Another 10 would be 1,000, and another 10 would be 10,000. So x must be 4. So you got 18 fishhook problems is really all you have. The title says logs, but really it's fishhook and then exponents. And we'll go over some of those on Wednesday.